right? So, okay. See, these two formulas, can you remember?
Yes, sir. Once we can we do that derivation alone, and then it will be
No, no,
easy for me
no,
to remember.
no. See, for NEET exam, you don't need derivation. I'll just tell the logic. Okay, I won't derive it. Okay. See, the thing is, when the speed is too low, the thing will try to slip down, right? Because
Yes, sir.
there are two forces along the surface of this road. One is Fc cos theta upwards, and the downward force is mg sin theta. Okay,
Yes, sir.
I'm not shown. This is mg sin theta. So whichever is dominant, the car will try to move in that direction. So when mg sin theta is dominant, in the sense like the thing is moving with low velocity, Fc will be low, right?
Yes, sir.
So it will try to slip down. In that case, the friction will try to act upwards.
Yes,
There,
sir.
there are two cases. One the speed is low. So in that case, this is the equation. The net, okay, this one, mg sin theta minus Fc, that is the net downward force, that will oppose the friction force. So when you put the limiting value, so this thing should be less than the limiting value of friction, and Fc is mv square by r, right? So v square, if since negative, v square will go on the other side. So we get the condition that v is greater than something, that will give v minimum. If v is greater than something means we have a value for v min,
So
right?
that n we have to take that mu as n or n cos theta, sir.
No, friction force is always mu n, total non-reaction.
So n only we have to take.
Yes, yes, friction force is always mu to n.
Okay.
Okay, right. So this will give me v min. So to get v max, the thing is going very fast. So in that case, this thing will dominate. Okay, so the car will try to move out. In the case, the friction force will act inwards.
Yes,
Okay.
sir.
Yes.
Yes, sir.
If the car is trying to move very fast, Fc cos theta will dominate. So the thing will try to move out or skid outside. So here the friction force will change its direction, will act inwards. So in that case, this is the equation. When it outward force is Fc cos theta minus mg sin theta, that should balance the friction force. But in the limiting condition, this thing should be less than this limiting. So from here, v square by r. So v square v will be less than something. That means that I have information about v max.
Yes, sir.
Okay, so this is the logic. You don't have to go to the derivation because it's not board exam. So finally, we have this result. So the way to remember this result is root gr or rg into tan of something. Okay, so in the case of friction not being there, so it is just tan theta because phi is related to friction.
Yes, sir.
So v min means the tan should be minimum angle because this tan of the angle is in the first quadrant. So in the first quadrant, tan will increase as theta is increasing. Okay, so theta minus phi is always in first quadrant. Okay, because both theta and phi are in first quadrant, so difference of the thing in first quadrant. So to get Vmax, I have to add these two angles. Okay, in the case of friction not being there, it will just be tan theta. And in the case of the road where there is no banking, in that case, theta is 0, right? If it is a flat road,
Yes, sir.
so in that case, theta will go. So this is R just Rg into mu because tan phi
Yes,
is
sir.
mu. So if you remember one of them, you can get other ones.
Yes, sir.
Okay, so you have to remember this formula. Otherwise, it's difficult. I mean, there is no other way. You have to remember this one. So this conical pendulum, you know, because this is a uniform circular motion. Because theta is fixed once, other things are fixed. The mass is fixed. The length of the string is fixed. Okay, only these two are the two variables. One, I can change the mass of this bob, or I can change the length of the string. If these two are fixed, theta is fixed. So when those things are fixed, it's a uniform circular motion. This friction force will balance the weight, and the friction force is mu into n, and n is given by the balance of the centrifugal force. This thing also, you just have to remember the result. See here in this case, to this vertical circular motion. It's like a vertical pendulum. So there are two conditions for the thing to complete the complete circle. One is the tension should not become zero anywhere, and the velocity of the bob should not become zero anywhere. Okay, so these two, tension should be greater than zero at all points, and the velocity should be greater than zero at all points. So these conditions will give the what should be the velocity at the lowest point. So this also you don't have to go. The logic is clear. After that, you just have to remember this result. So for the thing to complete this full circle, the velocity at the bottommost point is root 5 gr. Okay. And for the, so when that happens, at the topmost point, the velocity will be root gr, and the tension will become zero. So tension is at this point, just before this and after this, the tension will be some positive value. Okay, so the tension minimum is at the topmost point. So if it is becoming zero here, then it will manage to have tension at other points. Okay, so for it to complete the circle, the velocity at the lowermost point should be root 5 gr. So this is one thing you have to remember. And if the value is between, if it is less than root 5 gr and more than root 2 gr, so it will come up to beyond this half point, and somewhere it will leave here. And at this point, the tension will become zero, but velocity will still remain. So its axis, the thing is going to move as on a projectile motion from here. Okay, because tension becoming zero means the string is going to slack. String is going slack means string is not there. Okay, string is not there means something which is released the initial velocity is like a projectile motion. But this will be complicated. Most probably this will not come in NEET. But maybe just for checking the condition where the particle will leave the circle, if this is a condition, then it will leave the circle in this upper half. Okay, if it is still lower than root 2 gr, then it will leave somewhere, it will oscillate in the semicircle. Condition for oscillating the semicircle is the velocity will become zero first. Velocity will become zero, but tension will still be alive. Okay, this is the condition for thing being oscillating in form of a pendulum, simple pendulum, and less than a semicircle. Okay, so these three things you have to remember. One is root 5 gr. It will complete the full circle. Okay, greater than root 5 gr. And then if it is less than root 5 gr but greater than root 2 gr, it will leave somewhere in the upper half, here only, second quadrant, and it will become projectile motion after that. And if it is less than root 2 gr, it will oscillate as a simple pendulum. When it oscillates as a simple pendulum, tension will not become zero, but the velocity will become zero at the turning point. So these three things you have to remember: root 5 gr, root 4 gr, root 2 gr. So 5, 4, 2. Okay, and okay, let me.
So I have to remember that tension also, no, sir.
No, this is common sense. No, tension you don't. Tension can calculate. No, mv square by r. That will contribute. See here, the tension is because of tension is mg plus mv square by r, and v is known. Okay, you can quickly calculate.
And then the semicircle
in the top
half of the
hold on, in the topmost point it is mv square by r minus mg. Here it is plus mg. Sir. Here it is minus mg. So these 2 points are clear. So here mg will not contribute. It's just mv square by r because mg is vertically downwards and the tension is horizontal. So just mv square by r. Tension is mv square by r here. Clear? Weight is vertical. It will not contribute to the tension.
Means to complete the circle root 5 gr. Okay, to leave the circle less than root 2 gr. Am I right, sir?
Less than root 2 gr means simple pendulum. There are 3 stages. No, see, the most difficult thing is reaching this topmost point. So it's root 5 gr, and from here to here, it is less than root 5 gr but greater than root 2 gr. And still lower, yes, it will come here. So the velocity is more and more, it will go to higher and higher points.
Yes, sir. If it is greater than root 5 GR means?
It will continue. See, if it is root 5 GR, the tension is becoming 0 at the topmost point, no? If it is root 5 GR, tension will become 0 at the topmost point. But if it is more than that, the tension will be positive. Okay.
So that root 2 GR is that at bottommost point only we are calculating that velocity, no, sir?
Yeah.
Okay.
This U is at the initial point. You can remember like that U is for initial velocity. Initial velocity corresponds to the bottommost point. Okay.
Okay, if they ask that calculated velocity at that half circle means?
Yeah. Just energy conservation. Once you know your velocity at this point, you can use energy conservation. Gain in height will be loss in kinetic energy. Gain in height means gain in potential energy. Then you have to relate to loss in kinetic energy. Energy conservation will give. There are only two energies. One is kinetic energy, other one is gravitational potential energy.
That alone, can you please do it for an example?
Yeah, we'll solve some problem. Okay, let's try this question. A car is negotiating a curved road of radius r. The road is banked. So this is a banked road. The coefficient of friction between the tires and the road is mu s. The maximum safe velocity on this road is. This is a trivial question, theoretical question.
The direct formula only,
Yes,
no, sir?
yes.
Option A.
Yeah, because it's tan theta plus lambda or theta plus phi, and tan phi is mu s. Got it, no?
Yes, sir.
It's asking maximum speed. So this is the one. And tan mu is, this is the one. Tan phi is mu. Okay, this one. Yeah, this is related to the question you asked. So you understood the question? Just read it.
The magnitude of change in velocity
As it reaches the
as it reaches where the string is horizontal.
So initially it's u, it's here.
Yes, sir.
When it reaches the horizontal position, the direction of the velocity will be like this, no? Tangential.
Yes, sir.
So you have to get the velocity at this point. What is the velocity at that point? You know how to do?
You asked her to use that energy conservation.
Yes. Energy conservation only. So from that I can get the value of v, and direction is vertical. And to find the changing velocity, I have to do v minus u, and I have to do it vectorially.
So 2 root of 2 u square plus 2 gl.
Which option? Which option?
That option is not there.
Okay, then you have not done it correctly. So this 9. So from this I will get yeah, so you got the magnitude of u v as this one.
Yes.
V square minus 2gl. So and v is like this, right? So the change in velocity is vector v minus vector u.
Yes, sir.
This is change in velocity, right? So minus u is in this direction. U is towards right. No, so minus u is towards left. Okay, so the change in velocity is the magnitude of this hypotenuse, that is square root of v square plus v square. This logic is clear.
Well, vector also we can use, no sir. V square plus u square minus 2ab cos 90 degree, that will become 0.
Yeah. Same thing, right? U square plus v square only.
Yes, sir. Yes, sir.
So then?
Yeah, option A, sir.
Yeah. So, but you have to do v minus u because change in velocity. Here in this particular case, v plus u and v minus u, the magnitude is same. But concept-wise, is v minus u. You have to find out. So it is minus u this way. So you have to add these two vectors. That's around the diagonal of the parallelogram. Here the parallelogram is a rectangle. You can know.
Yes, sir.
This one, find the tension at point P. In terms of this is a trivial question.
Find the tension in the spring at point P in terms of VA theta point P. Okay. K equal to mv square mu plus mg cos theta.
You got the idea? Just draw the free body diagram.
Yes, sir.
And then tension should be equal to mv square by r plus mg component, right? The weight component.
Yes, sir.
This is the answer. It's just 1 minute.
But what the second expression I can't get at once, sir.
No, find the in terms of VA. Now we have to relate VA and VP, right? So this way energy conservation. You have to write one more equation. Right? Energy conservation between the points A and P. You have to eliminate VP, no?
Yes, sir.
In terms of VA, for that you have to write energy conservation between the points A and P. He's straight away using the formula, but you can. I don't like to remember the formula, so I'll just derive it quickly. It's not a difficult thing. This is only a theoretical question, so it will not come in NEET. Most probably it will not come, but it's problems might come based on this. So if you cannot remember the formula, then you have to derive it quickly. This is the same thing, right? V square is u square minus 2gl. Here L is r cos theta. So r minus r cos theta, right? There is a gain in height. The gain in height is this one, right? That is r minus r cos theta. That is r into 1 minus cos theta. So this is the gain in height. Okay, so v square equal to u square minus 2ga. That's what is got here. Is it clear?
So r minus r cos theta. How did it come, sir? I can't get it.
This is the gain in height, right?
Yes, sir.
That height is, you can write as this one, right? This one is how much?
R.
And what about this distance?
This distance. I don't know, sir.
From this triangle, this is r.
Okay.
So this is
Okay,
r.
r cos theta.
Okay.
Okay.
I have not drawn it properly. So it's up to here. And this is the height, right?
Yes, sir.
Yeah. So the height gained is r into 1 minus cos theta.
Okay, half mvp square.
So now everything is known Vp in terms of Va, theta, R, G. So
Yes, sir.
you substitute this thing, this is the answer. You don't have to do that. Okay, so this is the method.
Yes, I got it.
Okay, so basically velocity will keep on decreasing. At this point, theta is 0. So if you put theta equal to 0, this will become 1. So Vp will become Va. Right?
Yes, sir.
Okay. This one. This straight away you can use the result.
The lowest point. Okay, complete the circle. Okay, root 5 g.
Yeah. You can straight away take this answer. Okay, so it's so the tension should the tension is minimum here, so that the minimum tension is 0. The tension at the topmost point is mv square by r minus mg, or you can write like this also. From this, when the tension is 0, this will give me vps vps root gr, and vp and va I can relate by using energy conservation. Right? Got the method?
1 minute, sir.
So this vp is velocity at this point, no?
Yes, sir.
That will come by putting tension equal to 0. Because when you just completing the circle, the tension at the topmost point is 0.
Yes, sir. Okay.
So that will give me vp, and from vp I can get va by using energy conservation. That is the same as this formula only. So vp
Okay, sir.
we put as whatever root gr. Vp is root gr from here. Okay, so if I use that thing here, that is basically energy conservation, I'll get the velocity of the bottommost point as root 5 gr.
Yes, sir.
Okay, calculate the minimum velocity that should be provided the lowermost point of the particle can be. Okay, this is a slightly different problem. Here it is, the thing is kept inside a cabin or lift, which is moving up with acceleration g.
Okay, g plus gr. Root 5 into g plus g into r.
Yeah.
Okay. 2gr into 5, so 10g.
So g effective you have to take
2g.
Yeah. But if you want to go to the basics, like additional pseudo force will be there because of this thing. So mv square by r, that will be the velocity with respect to the cabin. Okay, so since you are sitting inside the cabin, there will be an additional pseudo force downwards. So in addition to the weight, there will be one more mg.
Yes, sir.
Find the height. Okay, here he has given the initial velocity of root 3 gl.
Okay, we have to.
So it is greater than root 2 gr, no? Root 2 gr means will come up to this point.
Yes, sir.
Somewhere here, it will leave, it will stop. So when it is stopping, t will become 0.
Yes, sir.
and velocity will be something. You have to find,
Height.
yeah, at this point. So you have to find this height. So write the expression for tension at angle theta. Yeah, you can call this angle alpha also. So find the value of alpha for which the tension becomes 0. This is 90 minus alpha. Okay, so mg cos, so tension is mg sine alpha equal to mv square by alpha, and this tension is 0. So for this, I don't have to find v, I just have to find v square. So g r is a radius of the length of the string into sine alpha. So from this I'm getting sine alpha. So the height is L plus L sine alpha. Okay, this is v, and then b square can relate to u square. Half m u square equal to half m v square plus mgh. And h is are you able to solve the problem?
No, sir.
See, basically I have two equations and two unknowns. So v square, I got one equation, right?
Yes, sir.
That is got by using this condition, tension becoming 0. And the second equation,
That I understood, sir.
energy conservation, this one half m u square, good half m v square plus mgh. Okay, so m I can cancel. And instead of h, I will use this one, L plus L sine alpha. Okay, so I'll have two equations in. So I just have to find L, and I have to eliminate v square. Okay, so u square equal to u square equal to v square plus 2gh, and h is equal to 1 plus sine alpha. And v square is gl sine alpha. So gl sine alpha, 2gl sine, so it's 3gl sine alpha.
ஏய் ஆனே குடும்ப மஞ்சள் உள்ள வந்து போ வெளியே போய் வெளியே
So from this I'll get L sine alpha. U square minus 2gl. Okay, so H is L plus L sin alpha. So H is L plus this thing. This is U square minus 2G, right? I have to write it properly. It's L plus 1 minus 2 by 3 plus U square by 3G. U is given as root 3GL. So U square is 3GL. Yeah, I got the answer. Did you follow the steps?
1 minute, sir.
It's not difficult, but it's just time consuming.
No, sir. How did you get?
Just
H is equal to L plus U square minus 2GL by 3G. After that?
Hold on. See, basically I have to, one is tension equal to 0. Okay, that will give me this one, V square equal to this one. Right?
Yes, sir.
And then I'll use energy conservation because I have to relate, I have to eliminate this V square. So this is the equation. So this one is
Yes,
clear.
sir. Yes, sir.
2GL. So V square equal to, sorry, V square equal to, so U square equal to V square plus 2GH. And H I'm writing as this one, L into 1 plus sin alpha.
Yes, sir.
Because I want to just keep two variables. So height I'm not increasing, height I'm adding in terms of alpha. Okay, and the string length.
Yes, sir.
So this is the one, and this thing. So and 2GL. So U square is this one. Sorry, V square is this one, GL sin alpha.
Yes, sir.
Okay, so here in this equation, I can find L sin alpha. Okay, basically I want to find alpha. Okay, and height is in terms of L sin alpha. Once I know alpha, I know H, no? And what I need for height is not alpha, L sin alpha. So I'm just trying to find L sin alpha, and L sin alpha is here. Okay, so I'm taking this L sin alpha here and taking other things on the other side. This is clear?
Yes, sir.
Okay.
Yes, sir.
So, and then after that, H is L plus L sin alpha.
Yes, sir.
And L sin alpha is this one. And this is here the tail is minus 2 by 3, and this is 1. So 1 minus 2 by 3 is L by 3. And then U square by 3G, U square by 3G, and U square is 3GL. So U square by 3G is L. So 1 plus 1 by 3 is 4 by 3.
They have given U square equal to 3JL. Where, sir?
Bottom in the figure.
Okay. Okay, 3GL, 4GL by 3G. 4 by 3?
Yeah, option
Yes,
B.
sir. Yes, sir.
Okay, so when the thing is leaving the circle in the upper half, tension will become 0. Okay,
Yes,
so
sir.
if you put velocity equal to 0, you get a wrong answer. The condition for this thing leaving is tension becoming 0.
Yes, sir.
This one, okay, this is okay. So right now we have seen this road thing, and then this vertical circle with the string, right? String and a mass. Okay, you can also have vertical motion, vertical circular motion like this. Okay, here there is a track, vertical track, and there is a bike. Okay, so the thing can go in this circle if under what condition? Is it possible to complete this circle like this?
Yes, sir. If that initial velocity is root 5 gr.
Yeah. So basically, if the velocity should not become very small. If the velocity becomes very small, that mv square by r, which is balancing, which is in this direction, that should balance the normal reaction and the weight component, right? There is no other force. There are only three forces here. One is the weight, and then the normal reaction, and the centrifugal force. Is that clear?
Yes, sir.
Basically, there is only one force, weight, and there's pseudo-centrifugal force. Normal reaction is just a reaction to the other forces. Okay, and this normal reaction should not become zero. If it is becoming zero, means then it's losing contact with the surface, so the thing is going to fall down. Okay.
Yes,
So
sir.
now,
And there won't be any friction here, sir.
yeah, neglecting the friction. It's
Okay.
actually the tire rolling, no?
Yes, sir.
So tire rolling means the chance of friction is very, very small. Okay.
Okay.
So you're neglecting the friction. So, right. So here, again, the condition for the thing to complete the circle is the normal reaction should not become zero. And the minimum normal reaction is the topmost point. So at this point, the normal reaction, the limiting case, will be just becoming zero. Okay, so if you use that condition, you'll get the condition for the velocity at the bottommost point as same as a string in this one, same condition, root 5 gr. Okay, that way you can remember
Yes, sir.
that.
Yes, sir.
Because if you draw the free body diagram, instead of T, you just have M.
Yes, sir.
So it's exactly same. But here that yeah, it's exactly so. So here also two conditions should be satisfied. One is the normal reaction should not become zero, and also the velocity should not become zero. So this is exactly same as a vertical pendulum. Okay, both should not be zero, and the
Yes, sir.
minimum normal reaction at the topmost point. So the limiting case at the topmost point, the normal reaction is just zero. So the same thing. So if it is less than root 2 gr, it will somewhere in here in the half circle. If it is greater than root 2 gr, it will end somewhere here. Okay.
Yes, sir.
Greater than root 2 gr and less than root 5 gr. Okay. Now this is a rod. Instead of this is also a vertical pendulum, but instead of a string, we have a rod. Okay. So here the condition, in the case of a string, the condition is the tension should not become zero. And what is the one more condition?
Velocity.
Velocity should not become zero. What about here
Yes,
in the
sir.
condition of this rod, pendulum with a rod instead of string? Are these two conditions still required?
No, sir.
Which one is not required?
Tension not equal to 0.
Why is it not required?
So here, can I say?
See, in the case of a string, if the tension becomes zero, the string will start slacking, no?
Huh.
So in the case of a rod, it will not slack. Okay, instead of that, the string will try to compress. See, the rod, if you try to pull it, it will stretch, right?
Yes, sir.
So in that case, the tension force will be like this. You will try to pull it back. Yes?
We can't pull that to a rod, no, sir. It is
We can
strong
pull.
enough to.
Why not? You take a stick in your hand and pull with both hands on the opposite sides. Try to increase its length. You're pulling it, right?
We can try, but we can't. Okay.
No, that's because it's rigid. But still, you can pull it by a very small amount. It is rigid, okay, but still the amount of extension will be very, very small.
Okay, sir.
The length will increase. This is what we are studying Young's modulus, no? Young's modulus experiment. If you take a rod and attach it to it, there will be an increase in length, no?
Yes, sir.
Theoretically, it's 100% rigid, but in terms of practical, it's not 100% rigid, so it will increase by a very, very small amount. Even the string thing, the length will not increase very much because we are assuming the string is not, it's a rigid string. Okay. Same thing is applicable to string. Why will the length of the string increase? If the length of the string
Okay,
is,
sir.
then the problem is going to get complicated. The assumption is string is not going to change very much. It will change very, very small amount. Okay, that small amount will give me the tension, required tension. Okay,
Yes, sir.
but in the case of string, as you try to, um, it will only pull. But in the case of rod, if the force is this way, okay, the rod is getting compressed, so the rod will try to put a force in this opposite direction. So the tension in the rod, it can either pull or it can push. Tension can act in
Yes, sir.
both ways. But in the case of string, when you try to compress it will just compress. It will not do anything. It will just slack. So tension not being equal to that's not a condition. So the only condition is V should not be 0. And the minimum V will be at the topmost point. How do you know that? By energy conservation. The velocity will be
Yes, sir. At maximum potential energy, so minimal kinetic energy.
Yeah.
Means
So
that.
to find the minimum velocity at the bottommost point, such that it is the topmost point, so you have to find the condition for the velocity at the topmost point becoming 0.
Yes, sir.
So if you use the energy conservation, you'll get this relation which I already derived. Vp square equal to Vp is this variable point. For the topmost point, we have to put the corresponding theta. This is the relation, right? This is just energy conservation.
Yes, sir.
Okay, so in this, if you put Vp equal to 0, you'll get the condition for Va as √4 gr. So in the case of a vertical pendulum, the velocity at the bottommost point is √5 gr. But in the case of rod, it's easier to complete the circle because this condition of tension is not there. Only the condition of velocity
Yes.
is there. So it is √4 gr. So the velocity required for a pendulum with rod, it's less strict. Okay, the velocity can be of lower value. So this is also you have to remember. For pendulum with rod, the velocity is less and is √4 gr. Okay.
Sir, in that P point they have given taken at lower circular, sir, here.
No, P point is maximum. See, the velocity, minimum velocity is here, no? P point is the highest point.
Then how did they take that length as r minus r cos theta, sir?
No. This is for a general derivation. Okay. When you put theta equal to 180 degrees, this thing will become -1. Cos theta will become -1. While deriving this formula, I was this position.
Okay. Okay, sir.
Then the mathematics will take care.
Okay, sir.
Okay, so cos theta is -1 and theta is measured from here, no?
Yes, sir.
Okay. If you don't want to use this thing, you just have to write energy conservation from here to here. The height difference is 2r.
Yes, sir. It'll be easier, no?
Yeah, that also you can do.
Okay, sir.
I don't try to remember the formula. I'll straight away write the energy conservation between these 2 points. And this is what is getting right. 1 plus 1 is 2. So the height difference is 2r.
Yes, sir.
Okay. So this is another vertical circular motion. But here you have a ring and then a bead. Okay. Bead means a sphere with a hole. Okay. So this inside this one. So here also the condition for thing to complete the circle. One is here what will be there? Tension will be there or not?
Tension will be there only, sir.
Where is the string? Where is the rod?
String, no, sir. You have written the
No.
dotted line as string.
No, there is no string. See, this is a solid ring, this one, and there is a bead. Bead means there is a sphere with a hole inside it.
Okay.
Okay. So there is no tension. So what is there?
But here normal reaction will be there, no, sir.
Yes. Normal reaction and then velocity. So the normal reaction should not be 0 and it won't be 0. So this is not exactly a criterion. So only the velocity not equal to 0 will be the criterion that will decide the minimum velocity. This is not a constraint. Okay. So again, this is same to the pendulum with a vertical rod, pendulum with a rigid rod. So the minimum velocity is √4 gr.
So it is same as that bike and the sphere,
No,
no sir. Then
see, but bike the normal reaction should not be 0.
and here also if there is no normal reaction, then the
No, hold on.
will
Here,
fall down, no.
hold on. This will not fall down. See, at the bottommost point, it will touch. Okay, hold on. Let me this bead will. Let me draw this bead bigly. So, and see, this is the hole in the bead. Okay.
Okay.
So, when it is at the bottommost point, the rod, which is it will touch the top part of the bead. This part of the bead. Okay. Got it, no? Because mg is downwards and mb square by r also is downwards. So this thing will try to fall down, right? So the rod which is touching this bead is the top part. There is a small hole, no? The hole has got some finite size. Okay, so the rod
Okay.
can, whatever the rod, the ring can touch this bead anywhere. So it will touch the top part. But when it comes here, okay, so the thing will try to fall down. So the bead will try to touch the outer part. Here will touch the inner part of the bead. Here will touch the outer part of the bead. So the surface which is in contact with the bead, it will change. Here it will be inner part, here will be outer part. So the normal reaction is not a problem at all. It's not a constraint. Normal reaction won't be 0. It will be satisfied always.
Okay.
So in the case of rod, the thing is changing from tension to compression, right?
Yes, sir.
So here the thing is changing from the normal reaction being at the inner surface to the normal reaction being at the outer surface.
Okay, sir.
So this thing will not give a constraint at all. This is automatically satisfied.
Okay, sir.
So the only constraint is velocity should not be 0, which is same as a rigid rod. So it's easier to satisfy this condition. So the velocity can be less and its value should be root 4 GR. Square root.
Yes, sir.
It is same as the pendulum with the rod. Okay. So this one here, this is a similar to the bead on a rod, but this here is a tube or a pipe. Okay, it's a smooth pipe or a tube. Inside the pipe, there is a rotating ball. So the ball will complete the circle if the two conditions, normal reaction and the velocity, should not be 0. The normal reaction won't be 0 because of the,
Yes, sir.
here the diagram is drawn wrongly. At the bottommost point, the ball will touch the outer surface of the pipe. When it comes here, somewhere it will touch the inner surface of the pipe.
Okay.
So the normal reaction not equal to 0 is automatically satisfied. So V not equal to 0 will give you the condition as same thing, root 4 GR.
Yes, sir.
So this ball inside a pipe and the bead on a ring and this pendulum with a rigid rod. Here the condition is only the velocity should not be 0, so it's easier to satisfy. So the velocity at the bottommost point should be root 4 GR or greater than that. But in the case of this vertical pendulum, that is with the string and also with the bike, where both normal reaction and velocity should not be 0, here it's difficult to satisfy, so the velocity should be greater. So it's root 5 GR.
Okay, sir.
Okay. Now solve this problem. Aspect to complete the circular loop. So here both normal reaction and velocity, both the constraint has to be satisfied. Is that clear?
Yes, sir. Yes,
It's like
sir.
a bike inside a track.
Okay. V minimum should be root 5 GR.
V minimum in the sense the velocity at this point.
Root 5 G R. Okay. R is what? Bar should be the radius. Okay, fine.
Understood the question?
Yes, sir.
What answer?
No, sir. At the topmost point, velocity is root G R.
No. See, at the bottommost point, this should be the velocity, right?
Yes, sir.
And this velocity I can get by dropping the thing from a particular height. So I have to write energy conservation between this point and this point.
Okay.
Okay. So this velocity I'm attaining by dropping the thing from this height. Okay. So what should be the height? The height is given. So what should be the corresponding R?
R should be 2 meter.
No.
2 meter.
So mgh plus 0 because it's being dropped. So this is the initial energy at the point X, and the energy at the bottommost point is potential energy is 0. Kinetic is half m velocity square, and the velocity is root 5 gr for it to complete the circle. So from this I'll get h and r relation. Okay, and h is given. So understood, no? Yes. Done. Your mic is off.
Yes, sir.
This one.
Initially, body of rest and sliding along frictionless just completes a vertical cycle. Okay. The same as h equal to r is equal to
This is exactly the same problem.
2h by 5. It is h is equal to r. Okay, height is equal to 5r by 2, sir, but r value they didn't give, no, sir.
R is d by 2.
R is
Diameter is
d by 2. Okay, d by 2. 5D by 4, sir.
Yeah, option D.
Yes, sir. D.
Got it, no?
Yes, sir.
So this thing is same like a vertical pendulum with a string. So both the tension and the velocity should not become zero. Here in the case, instead of tension, we have normal reaction. So both normal reaction and velocity should not become zero. So that gives a tougher condition. So the initial velocity at the bottommost point should be root 5 gr. Okay. So you have any questions from what we have studied so far? You have to revise. I'm just wondering why you're not doing it. This link also I have put you in your comment. Circular motion. Oh, it's all this one.
Option 4.
The universe visible. Okay, this is 14.4. Okay, this is also a question based on the formula. What is the correct option? It's in level, right?
And the level means theta 0, sir.
Yes, no banking.
Mu was or the root of.
So 12 is 2. Yes. Okay, question number 8. Understood the question?
Between 14 and 15, sir.
Three. Okay, option
14
3.
and 15.
Yeah. See, what does this weightlessness mean?
Normal reaction must be 0, no, sir.
So basically, the weight is you feel weight because of normal reaction. Question number 5. It's trivial, right?
Will be only that radial acceleration will be less.
Yeah. So you have to find m what?
V square by R.
Yeah, instead of v, can you do something else? Okay, just
R alpha.
no, v actually I
That is
acceleration. So just v square by r. We don't need m. So this is equal to it because theta is given, no? Theta and then time is given. So from there I get omega. So it's omega square r.
Yes, sir.
Omega is this 22 revolutions divided by 44 seconds. So 22 revolutions, 22 into 2 pi. That is the total theta divided by 44. That is omega. So what is the answer?
One by 2, 1 by 4 into radius will be 1. Okay. Option 2, sir, it is pi square.
Yeah. Okay, question number 3. What is omega I?
2 pi, sir. End of second revolution. Okay.
Initial omega I.
Zero.
Yeah. Because he has said begun. Okay, you have to read the question properly also. The motion has begun, no, so that means it's starting from rest. And what is omega final?
4 pi.
V final by r. Radius is d by pi. Radian per second. Okay, so you have to find alpha, right? How do you find alpha? And
AT by R, sir. AT by R.
And theta is given, no? How much is theta?
4 pi.
Yeah. So how do you find alpha now?
d theta by dt.
No.
Theta by. Sorry. Okay.
This you have to use because whenever V and U are known, initial and final, same thing you have to use for
That will be omega I square plus 2 alpha s only, no, sir.
Yeah, this is this for a linear motion. So here I have to put the corresponding angular motion. This is 0. What is the answer?
1 minute, sorry, 8. So can I use that v square is equal to u square plus 2as?
Yeah, that's what I used here. For
Then
angular.
v is equal to 80
No.
to 80 into s
No.
equal to.
You should not do that.
Why, sir?
This just for removing the formula I said. See here the concept is the angular velocity that then you have to convert everything to linear only. You can do that. Then you have to
Linear will be 280. Initial velocity 0, s equal to.
yeah.
Okay, 4 pi into 20 by pi. 80. Okay.
What is the answer?
1 by 2. Oh god. What must I have done? I don't know, sir.
Check again.
U square plus 2as. Alright. 80 square. Okay, I didn't make that one. 40 meter per second square, sir. Option 1, sir.
Okay. Yeah, it's option 1. But what mistake I'm making here? Omega f square equal to omega initial square plus 2 alpha theta, right? So omega final square is 4 pi square. Is that correct? So it is 16 pi square equal to 2 alpha theta is 4 pi, right? So 4 pi and 4 pi will cancel. So this is 2 pi. No, why is it not? What is wrong here? Oh, he's asking tangential acceleration. Okay, this is alpha. So this into.
Yes, sir.
So 80 is alpha.
R alpha.
So it is 2 pi into r is 20 by pi. So it's 40. Yeah.
So how did you find that alpha, sir? Alpha equal to?
See this one omega f square to omega I square plus 2 alpha theta, no? And omega.
Okay, from there. Okay.
Yeah. So alpha is 2 pi from here.
Yes, sir.
So now your laptop is working.
Yes, sir.
So it is not crashing now.
No, sir.
What did you do? Okay, this is a theoretical question. Question number 1.
I don't know, so seriously.
See, what? This is very trivial. This will be across this thing, no? This is a very first starting point. See, this is a.
They have given average velocity, no, sir.
Hold on. Mass is performing a vertical circular motion. The average velocity of a particle is increased. Yeah, that's just for confusing. That's not the important thing. Then at which point So basically the tension will break when, sorry, the string will break when the tension exceeds a certain value, right? String will break.
Yes, sir.
So in this, is the tension uniform in this vertical circular motion?
No, sir. Keeps
So
changing.
where is the tension maximum?
At the bottommost point.
So the chance of breaking is at the bottommost point, right?
Ten
If
tension.
it has to break, okay, B is the bottommost point here. Okay, so the tension is maximum at the bottommost point. So it's option 2.
Okay.
Possibility of breaking. Possibility of breaking is at the bottom, at the place where the tension is low.
Okay, sir.
It's option 2. See, B need not be exactly bottommost point. It can be slightly off also, like shown in the figure. But compared to C, D, and A, B has got the maximum tension, right?
Yes, sir.
It has to break at B. If it has to break. Okay, fine. So according to this one, we have to do modern physics now. Okay, kinematics we have done some part. I think you have to practice only. And this Newton laws of motion also a little bit done. Electrostatics, capacitance. Okay, and then yes, current electricity is also a little bit done. Work energy power, circular motion is also done. Thermal physics, Newton dimensions, magnetic fields. This is physics of materials, surface tension, capillary, all those things. So next I will do modern physics in class 12.
Okay, sir.
Okay, and in class 11, kinematics, Newton laws of motion, circular motion is done. Work energy power.
Work energy.
So this Akash module, they have mock test, right? No, they have. So all those questions in this particular topics, the exercise problems, you have done all of them.
No, sir. I didn't touch it. I didn't even touch them.
Okay, so okay, try to solve those questions in kinematics, Newton laws of motion, circular motion. These things you have covered, no?
Yes, sir.
So try to solve those problems from Akash module,
Yes, sir.
and then whatever you cannot solve, just let me know.
Okay, sir.
Because PYQs, I think we have done.
Yes, sir. Yes, sir.
Okay, and then even class 12 electrostatics is done, capacitance is done, current electricity is done. So even these three from Akash module, you try to solve. Why you didn't solve in previously? That's how you joined the coaching. No?
Um, I was not able to solve them, so I found them very difficult.
Okay.
And my teachers know they won't solve the doubts so easily. So my physics teacher was so busy.
Okay.
If I send screenshot of them, he will not respond, sir.
You should have some assistant, no? Usually in the coaching institutes, for doubt clearing, they have junior faculty.
But that they allotted separate teacher for doubt solving. But I don't like the teacher's teaching style, sir. My teacher was not able to solve that one. He was so busy.
Yeah, that's what I'm saying. The senior faculty will take the classes. Doubt solving will be done by junior faculty.
That faculty used another teaching methodology, sir. My faculty was using a different one.
Okay. Okay, so you have this snap, no? Or I can send it also. So okay, you know whatever we have covered in the class, right? So far I have covered. So try to solve the
Yes, sir.
corresponding Akash model problems, and then
Yes, sir.
divide time properly. So I think you will do that. So next I will do in the class 12 modern physics, and in class 11 work energy power.
Okay, sir.
Right. So today I think we can stop now.
Okay, sir.
You have any questions?
No, sir, no.
Okay. So tomorrow then 3:30.
So tomorrow, I don't know if I can attend that class because I'm going to visit my grandmother's home.
Okay. Your exams are coming, no? So you should postpone all other things.
Yes, sir.
Then, so someone might be there in your home, no?
What, sir?
Someone might be there in your home, or all are going.
All are, sir.
Okay.
The festival there, sir. This.
Okay. So only tomorrow, no?
Oh, only tomorrow.
Okay. So then we'll meet day after
Yes, sir.
Thursday, Friday. Okay, Friday at 3:30.
I'm not sure, sir, whether if I can't attend means I will send you message, sir.
Okay. So how many days festival?
One day only, sir. That Mariamman temple.
Okay. So okay, it might extend to one more day. Okay,
I'll
fine.
message you, sir, if I
Yeah,
can't
fine.
attend.
Yeah, fine. We'll stop now.
Okay, sir. Bye.
Yeah, bye.